Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at matrices, rectangular arrays of numbers enclosed in brackets like this. So this is an example of a matrix. So each of these individual numbers is called an entry. Now we usually represent matrices with capital letters like this. This here, a matrix that has only one column, columns are going down, it is a vector. So we can use matrices with one column to represent vectors. This is the same type of vector that you saw earlier in the course. This is the x component and this is the y component. Now here C is not a valid matrix. The reason is, in order to be a valid matrix, each row and each column has to have the same number of entries. So when we're talking about matrices, rows go across and columns go down. The order or size of a matrix is written as the number of rows by the number of columns. So A is 3 by 3. A has 3 rows going across, 3 columns going down. Because these two numbers are the same, it has the same number of rows and columns, we call a square matrix. On the other hand, this vector here has 2 rows, 2 going across, and only 1 column. So X is a 2 by 1 matrix. It is not square because it has a different number of rows and columns. So as I said before, we call it a vector if it only has 1 column. Now we use this little a and subscript ij to mean the entry in row I, column j. So in A, for example, the entry A23 means the entry in the second row. So we go to the second row, which is here, and 1, 2, third column. So here A sub 23 would be 4. Another important definition is the trace of a matrix is the sum of the elements on the leading diagonal. So the leading diagonal is this. It includes all of the entries in the matrix that have the same row and column number. So this is entry A11, A22, and A33. So the leading diagonal starts at the top left and goes diagonally. So the trace of matrix A is simply -2 plus 0 plus 6. So the trace of A, which we write like this, is equal to 4 as well. Now, the transpose of a matrix means you switch the column and rows. So this is matrix A. We write A transpose. So it's going to be a matrix as well, and we switch the column and rows. So see how here the first row was -2, 3, 5. So in A transpose, we just do the same numbers, but this time we're going down. The second row was 1, 0, 4, and the third row, 2, 8, 6, is now the third column of A transpose. So note that the leading diagonal stayed the same, but we just switched around the entries. For example, entry A21 in A becomes entry A12 in A transpose. We've just switched around the columns and rows. Let's now look at multiplication by a scalar and also addition and subtraction. So let's say I have these 3 matrices here. So we're going to start with scalar multiplication. You can take a matrix A and multiply it by a scalar really easily. For example, the number 3 here is a scalar as opposed to a matrix. So to multiply a matrix by a scalar is really easy. You just take each entry one by one and multiply by that scalar. 2 times 3, -3 times 3, 0 by 3. How easy is that? Now let's look at adding together 2 matrices. You can only add together 2 matrices if they are the exact same size. So in order to add together 2 matrices, we simply add together the elements that have the same row and column number. So A11 and B11 becomes A plus B11. Entry in row 1, column 1, plus entry in row 1, column 1 equals entry in row 1, column 1, 1 plus 6. Similarly, we go 2 plus 7 is equal to 9, -3 plus 8 is 5, and 0 plus 9 is 9. It works similarly for subtracting. So for a minus b, we go 1 minus 6 is negative 5, 2 minus 7 is negative 5, negative 3 minus 8, 0 minus 9. So as I said before, you can only add or subtract matrices if they are the same size, the same order. We could add and subtract A and B because they're both 2 by 2 matrices. We can't, however, do something like A plus V. We can't add together two matrices of a different size. V here is a 2 by 1 matrix. A is 2 by 2. Their orders are different. You cannot add or subtract matrices if their orders are different. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.